Stars are giant balls of gas that light up our universe. They are born, they shine brightly for millions or billions of years, and then they die. Some stars end their lives with a whimper, slowly fading away. Others go out with a bang, exploding as brilliant supernovae. Imagine the biggest fireworks show you've ever seen multiplied by 1 billion times. That's how bright a supernova can be, briefly outshining an entire galaxy. Supernovae are not just dazzling cosmic displays, they are crucial to the universe's evolution. These explosions scatter the elements forged deep within a star's heart, like oxygen, carbon, and iron. These elements become the building blocks of new stars, planets, and even life itself. Without supernovae, we wouldn't be here. There are two main types of supernovae. Type 1 supernovae occur in binary star systems, where a white dwarf star steals material from its companion star. This material builds up on the white dwarf's surface, eventually triggering a runaway nuclear fusion reaction that obliterates the star in a colossal explosion. Type 2 supernovae happen when massive stars, much larger than our Sun, exhaust their nuclear fuel. The core of the star collapses under its own gravity, triggering a shockwave that rips through the star's outer layers and blasts them into space. This explosion is what we observe as a supernova. Now you might be wondering, what about our Sun? Will it explode as a supernova one day? Thankfully, the answer is no. Our Sun is a relatively small star, not nearly massive enough to go supernova. It will eventually run out of fuel, but instead of exploding, it will expand into a red giant, engulfing the inner planets, including Earth. But don't worry, this won't happen for another 5 billion years. After its red giant phase, the Sun will shrink down to a white dwarf, slowly cooling down over trillions of years. So, while our Sun won't end its life with a bang, it still has a fascinating journey ahead of it. Let's imagine for a moment that our Sun did have enough mass to go supernova. What would happen if it exploded today? The first thing we would notice is a sudden, blinding flash of light. The Sun would become millions of times brighter than normal, instantly vaporizing anything on the side of Earth facing the blast. The intense heat and radiation from the supernova would scorch the Earth's surface, boiling away oceans and melting mountains. The atmosphere would be stripped away, leaving our planet a barren, lifeless husk. Section 5. Earth in the blast zone. Immediate consequences. The initial blast of light and heat would only be the beginning of the story. Next, a powerful shock wave of superheated gas and particles, traveling at nearly the speed of light, would slam into Earth. This shock wave would be powerful enough to shatter our planet into pieces. Even if Earth somehow survived the initial blast and shock wave, the long-term effects of the supernova would be equally devastating. The intense radiation from the supernova would continue to bombard our solar system for centuries, making it impossible for life to re-emerge. Section 6. Echoes of the cataclysm. Long-term effects. The remnants of the supernova, a vast cloud of expanding gas and dust, would continue to spread outwards for thousands of years. This expanding nebula would be visible across the galaxy, a testament to the Sun's final, explosive act. Within this nebula, the elements forged in the Sun's core would mix with interstellar gas and dust, eventually forming new stars and planetary systems. The death of our Sun, though catastrophic for Earth, would sow the seeds for new life to arise elsewhere in the cosmos. Section 7. Supernovae. Rare cosmic fireworks. Fortunately, supernova explosions are incredibly rare events. In a galaxy like our own Milky Way, which contains billions of stars, only 2 or 3 supernovae occur every century. The last supernova observed in our galaxy was Kepler's supernova, which lit up the night sky in 1604. This rarity makes supernovae all the more special. Each explosion is a unique opportunity for astronomers to study the life and death of stars and to unravel the mysteries of the universe. Section 8. Probing the cosmic afterglow. Studying supernova remnants. When a supernova explodes, it leaves behind a glowing remnant, a cloud of expanding gas and dust that can be observed for thousands of years. Astronomers study these remnants to learn about the original star that exploded, the elements it created, and the physics of these powerful explosions. By analyzing the light from supernova remnants, astronomers can determine their chemical composition, temperature, and speed. This information helps us understand how supernovae enrich galaxies with heavy elements and influence the formation of new stars and planets. Section 9 Supernovae, illuminating the universe's secrets. Supernovae are not just destructive events, they are also powerful tools for understanding the universe. In 1998, astronomers studying distant supernovae made a groundbreaking discovery. The expansion of the universe is accelerating. This discovery, which earned the researchers the Nobel Prize in Physics, revolutionized our understanding of cosmology and led to the development of the theory of dark energy, a mysterious force that is pushing the universe apart. Supernovae, these brilliant explosions that mark the end of a star's life, continue to illuminate the deepest secrets of the cosmos.